Ever wondered how machine learning algorithms, specifically classification algorithms, work to sort and categorize vast amounts of data? One such algorithm that stands out due to its unique approach is NuSupport Vector Classification, or NuSVC for short. A NuSVC is a type of support vector machine, or SVM, and it's a powerful tool used in machine learning. SVMs are a set of supervised learning methods used for classification and regression analysis. But NuSVC has an interesting twist. It introduces a parameter, nu, which controls the number of support vectors and training errors. Now, let's dig deeper into this fascinating algorithm. The first step in understanding NuSVC is to grasp the concept of SVMs. Imagine a set of data points on a graph. SVMs work by finding a line, or in higher dimensions, a hyperplane, that best separates these data points into classes. This line is chosen to maximize the distance, or margin, between itself and the nearest points in each of the two classes, which are known as support vectors. But what if the data isn't linearly separable? Well, that's where the kernel trick comes in. The kernel trick transforms the data into a higher dimension where it can be separated linearly. This is a fundamental part of SVMs and, by extension, NuSVC. Now, what sets NuSVC apart? It's the nu parameter. Nu is a parameter in the range of 0 to 1. It provides an upper bound on the fraction of training errors and a lower bound of the fraction of support vectors. So how does NuSVC work? The NuSVC algorithm begins by using the kernel trick to transform the data into a higher dimension. Then, it finds the hyperplane that separates the classes while considering the nu parameter. Remember, nu sets a limit on the number of errors and support vectors. It's a balancing act. The algorithm aims to keep the number of errors below the upper bound set by nu, while also ensuring that the number of support vectors is above the lower bound set by nu. To sum it all up, NuSVC is a type of support vector machine that introduces a unique parameter, nu. This parameter sets a limit on the number of training errors and support vectors, providing a way to control the balance between the two. The NuSVC algorithm uses the kernel trick to transform the data, finds the hyperplane that separates the classes, and then takes the nu parameter into account. NuSVC is a powerful tool in machine learning, providing a unique way to handle classification problems. It's a testament to the versatility and adaptability of machine learning algorithms. So, the next time you come across a classification problem, why not consider NuSVC? It might just be the perfect tool for the job.